Hello and welcome to the Tech for Climate podcast. I'm Guillaume, your host, and each week I'm fortunate to share with you stories from climate tech founders, investors, and corporations sharing their unique insights into this fast-moving industry. Eventually, like me, you will learn, discover, and get inspired by those unique men and women who are contributing to the fight against climate change, and I hope it will help you to take a step in this formidable movement. So before we start, I just want to share a few words about us, as this podcast is just the tip of the iceberg of what we do at Startup Basecamp to support the climate tech movement. Our mission is to accelerate capital deployment towards climate tech founders, allowing them to focus on scaling their solutions. How do we do that? Every day, we help founders access to resources and connection and gain the visibility they need to expand their growth. We do this in a number of ways with a membership platform, a Slack group with a growing number of founders, investors, and experts from around the world. And recently, we went one step further with the matching services to connect founders with top climate tech investors. Keep in mind that we are able to do all of this thanks to the support of our listeners and our members. So please like and subscribe, share one episode with a friend, join a community, and if you haven't already done so, make a small donation to support our work. It really means the world to us. And now, enjoy the show! Hi everyone, in this new episode of Founder Series, we sat down and had a concrete discussion with Mario Schmitt, co-founder and CEO of Ecolocked, which turns biochar into an additive for concrete that partially replaces cement and other emission-intensive ingredients to make concrete carbon neutral, lighter, more insulating, along with a couple of further benefits. As an economist training, but an environmentalist by nature, Mario was already alarmed by climate change at 18, but didn't know how to address it at that time. After working in a consulting firm for several years, but still drawn by his love of nature and biodiversity, he knew he wanted to make an impact while he was still young and decided to start Ecolocked after meeting his co-founder. Concrete, you will learn that during this episode, is the second most used material in the world after water, and with that use comes a lot of emissions. In this episode, we examine those emissions, which ones are harder to abate, and how are they addressed by Ecolocked's solution. We then take a wider view of the industry. How is the market organized? Who are the main actors? What are the current regulatory frameworks in place? In doing so, we get a concrete understanding of Ecolocked's solution and how it fits in the larger sector. During the second part of the show, we learn where Mario has focused his efforts to accelerate his fundraising process and what has been successful. We then learn how Mario keeps up his energy and why sometimes you just need to take a break. Mario, welcome to the show. Hi Mario, welcome to the Tech for Climate podcast. I'm super happy to have you here with us today on the show. I believe it's going to be a great opportunity to hear your story and learn more about your exciting adventure to make climate positive concrete a reality with Ecolocked, which has been developing and using carbon negative materials to create an emission-free built environment, starting with concrete, I believe. So welcome to the show.
Thank you very much, Guillaume. I'm very happy to be here.
Super excited to hear your story. So maybe, as usual, we like to start with a 30-second introduction about the company. So if you could give that to the audience here.
Yeah, sure. So what Ecolock does is essentially turn captured carbon in the form of biochar or biocarbon, which most of the audience will know, I think, into a functional resource for concrete. So in fact, what we are developing is a process for turning biochar into an additive for concrete that partially replaces cement and partially replaces other concrete ingredients, the emission-intensive ones. And then we can make the concrete carbon neutral and lighter and more insulating, and with a couple of further benefits. And the great thing about that is we can do that agnostic of location and of feedstock to really make it globally scalable. Why we do that is two things. Like on the one hand, of course, we want to provide the construction industry with a solution for decarbonization, but also we want to enable carbon removal at scale around the globe. And we really believe that biochar is one of the most cost-effective and market-ready, right, available technologies that really just is lacking a scalable end use case.
So let's start from the top in the show. We like to start with the speaker as a human, as a person, more than the whole journey as an entrepreneur at first. So maybe you can share with us a little bit about your personal story and background. I mean, as I always ask, I mean, what are you passionate about? What do you love to do besides building Ecolocked? I mean, what makes you feel inspired or like your best self? Who is Mario?
Yeah. I think so. What has always inspired me a lot is, in fact, nature, which is a good thing for, I guess, a climate or environmental founder. But it's true because that's really the place where I can be most myself, most relaxed, and also be most inspired and get the greatest ideas, right? Like, of course, there are many other things that I like to do. Music inspires me a lot. Doing different kinds of sports, ideally also in nature. But there's always this sort of theme, I guess, of nature, which has always been an important place for me. And that's also why I guess at a very early stage in my career, I already knew that I wanted to make it about environmental preservation, nature preservation. And I just back then, I mean, that was when I was 18, I was reading this huge report on climate change. I was shocked by why nobody was doing anything. And obviously at that time, I didn't know how, right? But now here I am.
Fantastic. So I think that's a good segue to kind of like understand like prior to the launch of Ecolocked. I mean, what was your work and life experience in a way that gave you an edge to start the company? If you have maybe one or two pieces of experience that helped you to be a better founder today.
I mean, so what led me to being an entrepreneur is not that I always knew I wanted to be an entrepreneur, but it's more like that sort of I noticed that the topics I care about, which is the climate crisis, the biodiversity crisis, require entrepreneurial solutions. So like I'm an economist by training, right? And before founding Ecolocked, I was working for a long time at the Boston Consulting Group, which was great. I saw a lot of different industries. And what I think also helped me in my role now is that I saw different industries really from the inside, right? So at the factory level, how do they work? What do they struggle with? Why is decarbonization also difficult? Well, it's a lot more difficult than if you just write smart recommendations on paper. Which I guess is also a nice segue into why then the decision to become an entrepreneur. I realized for myself that sort of as a consultant, you leave the decision to implement all these smart recommendations you come up with to the client, which can be the industry or which can be the government or whoever. But like in the face of the urgency that we have with these crises, that's not really a good strategy because we know that there's this element of cost, and as soon as something is still more expensive in large industries, it's super tough to make it happen. And that's sort of in 2021, I just realized, okay, if I want to still have a huge impact while I'm young, then entrepreneurship is the best way to do that. And so I was looking out for options to really help set up and a company that is, I guess, developing a technological solution, making that cheaper for industries to transform, so that this transformation really happens. And then maybe I stop here, but sort of how it goes on is that then I meet my co-founder Michael, and the whole story of Ecolocked starts.
And I think before going into detail of the genesis of the whole story of Ecolocked, as I mentioned prior to the interview, we like to kind of take a zoom out at the industry in specific and in general. So I'd like to understand a little bit more about your experience in this concrete industry, and understand a little bit like more the contribution to climate change today. I mean, we hear a lot about it, and maybe we can start with like trying to go a little bit deeper and to put things back into perspective. Maybe you could like help us to understand the problem and share with us some data regarding the concrete industry in itself, the different and understanding a little bit like also like the different type of concrete used in the industry, the elements that in a way are generating during the whole life cycle, the greenhouse gas emission and the contribution that has that creates this massive problem.
Yeah. So maybe I start by saying that concrete is the second most used material in the world after water, right? So in fact, it's actually the most used solid material in the whole world. It's a 600 billion roughly global market. And while we are always like thinking about other ways to build, right, with wood, for example, which is actually a great solution for residential buildings and for certain other applications, still I think it's the World Resources Institute that predicts global concrete consumption to double until 2060. So that's where we are, and already now we have 8% of global emissions in concrete, and it's one of the industries that's hardest to decarbonize, and I'm going to say why in a second, which is sort of about the process, right? But then with these numbers, we can imagine sort of where this is going to go in terms of emissions. Now, how that happens. So for concrete, what you need is simplified, right? There's tons of different concrete. There's different strength grades. There's different ways of application. The biggest one is ready-mix concrete. That's about 80% of the market, right? That's these concrete, the trucks you see on the highway who transport that to construction sites. And then you have precast elements, which is like floor slabs, for example, or roof tiles. And then you have sort of do-it-yourself. And I guess you have decorative concrete and 3D printed, like the smaller sections. Now, what you need in general is cement, is water, and is different aggregates like gravel and sand. The aggregates, they have more of a biodiversity footprint, in fact, especially the sand, because you need a certain type of sand, and you cannot just take desert sand because it has like the wrong shape, which is becoming an issue because, like, at least in Central Europe, we're running out of that sand, so we need to dredge up more and more from riverbeds. So there you have an ecosystem issue, actually. But the climate issue is really the cement, and how that cement is made. So cement is like a combination of calcium oxide, you have aluminum oxide, you have silica oxide, and a few other components in there. And the problem is really in the production of that, this cement clinker, as it's called. You're essentially transforming calcium carbonate, which is limestone, into calcium oxide and CO2, right? I need to heat it up to like about 1,450 degrees Celsius. And this process, this reduction process, essentially causes the reaction between carbon and oxygen that just leads to the release of CO2. And this is such an sort of inherent part of how concrete is made that so far there's not been many solutions to this emission problem, because you need cement clinker as a binder.
So I think it's a good segue to move slowly towards like what are the different technology or alternatives besides yours that you are seeing getting some traction to decarbonize this concrete. And I guess most of them are focusing on the cement clinker, or these other part of the cement, the I would say the concrete mix that are also like popping up as alternative that in a way helps to decrease the footprint. As we understand anyway, the footprint, the major one is on the cement production
Exactly.
in itself.
Yeah, so maybe I can break these up into like 3 or 4 categories. If I start with the first one, that's like the ones that the industry is already using, already applying. The first one is very simply concrete recycling, which essentially means when a building is disassembled, you break up the concrete, you grind it, and what you end up with is particles that can be at least used as an aggregate replacement, and sometimes a small part can be used as a cement replacement. But it's not a big part of emissions you're saving with that, but it's something the industry has sort of is adopting at scale because it just makes a lot of sense. The second one, which has long been sort of the one silver bullet or solution for the concrete industry, is secondary cementitious materials, also called geopolymers. So what you have in there is like fly ash, a byproduct from burning coal, and you have blast furnace slag. Um, both of these are byproducts from sort of fossil powered processes, and with those you can partially replace the cement. So to make it a bit more illustrative, typically a ton of cement has about 800 kilograms of CO2, or it used to be 900 even, right? In some jurisdictions, I think in the US it's still higher. Um, with the use of secondary cementitious materials, you can already get down to 500, 550. I mean, different companies have come up with different mixes. So this is a good solution, but for the moment, right? But in the future, we may have an issue there because we're trying to phase out fossil coal burning. So unless we want to sort of ship this fly ash around the world from those countries that still use fossil coal, we're going to have an issue there. And the industry has seen that. Now, if it comes to what the industry is then trying to use as sort of the go-to solution for abating the rest of the emissions, source capture systems like oxyfuel or Aminwäsche. I don't know what that in English, in fact, but the the classic process, the post-combustion one. And we all know how expensive that is. I mean, I'm sure there's been other interviews where that was a topic. We've seen recent plants being installed for like 150 million, 200 million euros extra. And what we believe is just that it's going to take a long time until this is rolled out at scale and really abating the emissions to the extent that we need it. It's going to be 2040 at least until this is really done and installed in all the cement plants. So that can't be the only solution, right? And then you have two more clusters, which are like I would call them the startup clusters. And one of them is solutions that are going to be market ready soon or are market ready already, without sort of saying, I'm not the expert, I don't have the sort of insight into what all these companies are doing, right? But that's our outside perspective. And the other one are those that take a little bit longer. But if we look at what's getting market ready soon, we're a big fan, for example, of mineralization, right? So capturing CO2, for example, via direct air capture, mineralizing it in a rock like olivine rock, for example, grinding that up, and you have a great binder replacement. So you can replace a big part of cement. It's also not very cheap, I think, but it's a great solution. Now, then, secondly, you have sort of the carbon curing, I guess, or recarbonization, whatever we want to call it. But carbon cure, these companies are known, where you essentially use less limestone in the beginning, and then you inject CO2 as a gas later on, which supports the curing process, and you create calcium carbonate again. Also a great process. One cool thing, by the way, is that why we like these processes and have looked into them is that we can actually combine our solution with theirs, and there's even sort of a mutual reinforcement. We're going to get to that later, I guess, but when you use biochar in a in a concrete like that, you have that positive effect. What else is there? I think there's sort of AI-based optimization.
Here we are. We are back. So we got a little emergency fire alarm during the recording of this episode. That's why for the one who are watching on YouTube, you will notice that the background of Mario changed. So Mario, everything fine? You still have an office?
Yeah, a bit of action on but you know, as a founder, you're always firefighting. So I guess that's a very classic day then.
Fantastic. So you are like finalizing the different alternatives. I think one category was missing that you wanted to wrap that up before we keep going into the interview.
Yeah, right. So I was speaking about this category where like market ready solutions are available now or very soon, and where we can see a lot of cooperation potential also with our solutions, where essentially a lot of those are focused on replacing cement clinker as a binder, partially or fully. And you can sort of stack that with our carbon negative additive, and then together you really get to carbon negative. The final category is sort of the more explorative solutions, but which are really fascinating. Really fascinating. It just will take quite a while until that's market ready. But I believe when it's market ready, as far as I understood, it's actually going to be quite cost competitive. And they are replacing calcium carbonate with calcium silicate. So they're really sort of turning around to how cement is made. And then some others that I would see in this category is sort of the biocements that grow like cement out of bacteria. Um, and I think once they break through, that can really fundamentally change the industry. But of course, they are facing the challenge of really going against the big cement players rather than sort of, you know, going jointly with the industry. So it will be interesting how that pans out then.
Well, thank you so much for sharing this whole perspective. Now that you understand a bit better the source of the problem, some potential alternatives. I think this is a good segue to what you just said, like to get more complete understanding of the context. If you could maybe tell us a little bit more about like who are the main actors in the concrete industry today and how the market is organized. I mean, what are their limitations or incentive in a way to take initiative to decarbonize the industry?
Mm-hmm. Yeah, and that's actually quite a complex question. So I'm going to try to be structured and keep it simple. But I mean, essentially the types of actors you have in the value chain, right? If we maybe start at the end of it, you have whoever is building a structure or like an infrastructure or a building, right? So this can be real estate developers, or it can be residential owners, or it can be municipalities. Actually, public procurement in some countries, it's like 50% of the market. In others, it's like 30, but it's quite substantial. So these are the guys who actually sort of set the criteria, like what do I want to have in my building in terms of materials? What footprint should it have? And what am I willing to pay for this? And well, needless to say, but up until now, most people just cared about sort of how does it look, what functionality does it have, how much will it cost, and cost played a big role. And CO2 footprint, not a big one, to be fair. Especially embodied CO2, right? Maybe that's an important distinction to make here. Like a big part of the industry is caring now about operational CO2 from HVAC, energy consumption essentially, and embodied CO2 is just sort of shaping up as a topic. Now, these guys set the criteria then for procuring materials, which is regularly done by construction companies. Like, you know, we all know some construction companies, some big ones in our countries. And so if the budget is set very narrow, then those guys will just decide based on cost. That's the extreme case. Then you have different degrees of construction companies. You have sort of those that take care of the raw structure, subcontractors often, and then you have like the main sort of turnkey provider or general contractor, GC, it's often called. So these, for us as a company and for many others in the industry, they are enablers, decision makers. They are the ones who really create the pull. So if they are willing to pay more for a material because it's green, because they can benefit from it, and we can go into how they can benefit from it later. But if they do that, that's a big pull. that sort of can also change how concrete manufacturers then take decisions in terms of the materials they procure. Now, then next step before that, you have the actual concrete manufacturers. What's very interesting is that this is a very, very fragmented market. So like where you're sitting, where I'm sitting, like in a radius of 50 kilometers, there's going to be a concrete manufacturer. Especially as with ready-mix concrete, you can usually not transport it for longer than 50 kilometers. So that's why I'm saying this radius. And so that's why this is very fragmented. Some of the concrete manufacturers are vertically integrated from the big cement players, but you also have a lot of independent ones that you can work with. And of course, then you have those that focus more on precast and those that focus more on ready-mix. And then finally, step before that is the big cement players. And I think here, I mean, we all know them, so I can drop a few names, I guess. Like you have Holcim, you have Cemex. In Germany, we have Heidelberg Materials here, and then there's a couple more. Of course, there's a lot in Asia, right? But these are just to say a few names. So this is a very concentrated market, in fact, with these big players having their operations everywhere, delivering cement to the concrete manufacturers where it's then like physically produced. And when it now comes to the question, like who has an incentive to change there, I already touched upon that, right? With the sort of decision makers at the end of the value chain. As a real estate developer or as a municipality, more and more I actually want to or have to sort of take care of my embodied CO2 footprint from the building. So how much CO2 has been emitted up until the point when the building gets operational. How that comes into play is nowadays, I mean, it's just mostly reporting, to be fair, and not so much sort of fixed criteria yet. But what we see up and coming, a couple of European countries have already implemented that, is that you're going to have reporting requirements for sort of the maximum amount of CO2 or general for the amount of CO2 that can be in the materials you use. And then there's going to be thresholds for the maximum. So this is going to come, especially in public procurement. And then in the private sector, what you have there, I think what plays a role is, you know, like in any value chain, labeling, essentially. So you can get sustainable building certifications. So like in Germany, we have DGNB. Then globally, there's BREEAM, there's LEED, there's the CSC, which is the sustainable. I'm not sure if it's Climate Sustainability Council or if it's Construction Sustainability Council, right? So you can get these certifications, and then as a developer, you benefit from that. For example, because if you're building an office building, right, and the companies moving in there want sort of a proof that you actually looked at sustainability, then you can prove that. In general, that also increases the value of your construction project, and it gets you access to maybe green sort of funding sources. So this is really like sort of, if we look at the end of the value chain, even if regulation is not being strict yet, and if there's not sort of super formal absolute needs to do that, you still have incentives. And if we look at sort of the center of the value chain, so more like the cement and concrete producers, then we're really looking at a more of a cost game. It's not true throughout all segments, right? There's premium segments, but still. So there, what really plays a role is, is there any regulation forcing you to reduce CO2? And if I'm a cement producer in Europe, I'm part of the ETS, the European Emission Trading Scheme. I have to show certificates for any amount that I'm not reducing. Unfortunately, these emission allowances are still being distributed for free. And this is going to be phased out very soon, but that's why sort of, even if we look there at the industry, the incentives are not super strict yet. They're just getting there, but right now we're rather looking at sort of using sustainability for reporting, right? You have your nice looking sustainability report at the end of the year where you want to say, hey, my concrete is actually carbon neutral. That was a bit long, but as I said, it's a
No,
complex
I think that's
industry.
super valuable to really understand this more regulatory, push. And do you see to close this section quickly? Like, do you see any missing ones on the maybe production and cement producers one that should be implemented, or maybe a major difference between the European market, as you mentioned, or the US market that could, in a way, accelerate the full decarbonization of the concrete industry?
Yeah, I mean, certainly, once these emission allowances are being phased out, right, that can have a big impact. So if we just look at sort of incentives, then I think these maximum thresholds reporting requirements is, just like we do it in other industries, this would be providing sort of planning certainty for the industry for something that they need to do anyways. So I think thereby it would streamline sort of the I guess the more low short-term need of the industry for financial accounting and sort of project ROI calculation with the long-term need to decarbonize, which is going to come anyways, right? And that's why I think the more EU initiatives and outside EU we have there, the better. If we look at other markets, I mean, it's really fragmented. As far as I know, in the US, there's no mandatory requirement like that yet. But what the US is doing very well is working with subsidies for, as part of the IRA now, for example, for sort of innovative technologies that help to decarbonize concrete. So I guess it's a different kind of fiscal policy there, which we are just starting to, I guess, copy a little bit in Europe, but which is not so pronounced here yet. But that could have a huge impact as well. And I guess finally, and this is something that all new concrete materials are facing, is approval, which is a big challenge for us because so when you develop a new concrete material and you want to sort of not use it just for 1, 2, 3 projects and sort of get approval on an individual basis, but you actually want to get your CE mark in Europe, for example, and there's different ones in other markets, then you have to go through a bureaucratic approval process. And interestingly, how that works is the certifications are rather based nowadays on sort of the material ideally being as close to the ones I know in terms of shape and looks and color, etc., as possible, and then it goes faster. But if it's fundamentally a different material, it doesn't matter so much that actually the performance works well. You still have to go through these long processes. In our case, for example, we can show with our data that it works for ready mixed concrete, but still we're going to have to go through these processes, and that can take like 1.5, 2 years. Which, by the way, doesn't mean that we can not do projects until then. There's sort of segments within concrete that don't require that, where you just show your data plus external validation, and then the producer says, okay, I believe that's proof enough, let's do a project. So that's, for example, in many precast segments. So that's great, and we can still do some RMC projects based on individual approval, but for the sort of to really scale this up, you need the broad approval, and that's especially for RMC.
Okay. Thank you so much for covering this and extensively the whole concrete industry in itself. So now let's go deeper into Ecolocked. You already touch up a little bit on that, but if you could reshare with us like the story behind it, the gap that you identified initially, and in a way why did Ecolocked had to exist?
Mm-hmm. Yeah, sure. So really where we come from, as I touched upon it, was that so my co-founder was researching biochar or biocarbon, as we like to call it in general, and being sort of excited about the potential of this technology as a carbon removal technology, right? Why? Well, I probably don't have to go into detail about how biochar is produced, but essentially by, pyrolyzing waste biomass, what you get is you remove up to 3 tons of CO2 per ton of this material. Then you get the material itself, which is highly functional, can be used in many different industries, like construction, for example. And then modern pyrolysis systems even make use of the rest of the components of the waste biomass. It ends up in a gas that can be used for energy generation. So that's great. Now, we looked at this material and we thought, okay, how can we really scale this up globally? And we looked at sort of the commonly known applications, of which the most popular one is agriculture. So we interviewed a lot of farmers, obviously very centered on Central Europe, but still representative to some extent, I would say. And we noticed that there's just sort of a gap between their ability to pay for an additional material that you distribute on the acres and the time of returns for that, which is like in 5 years from now, maybe earliest, when the yields get better, when sort of more humus is formed, the water retention capacity is enhanced, and all these things. And so then we sort of concluded, okay, agriculture is going to be quite difficult to scale up with biochar globally. So what else can you do? What industry is there that is willing to pay for this material, ideally because you replace something else, right, that they are currently paying for, and where we can also provide a scalable sink for it. And it turns out that actually concrete is the most permanent sink you can imagine for biochar. Why is that? Because, and we're going to go into that later, right? But even if the building is disassembled, the concrete is ground up, as we were saying in the beginning, the biochar particles stay bound to the calcium particles, and so it can be reused. Still, no emissions are released, and that's being more and more sort of acknowledged also by experts in the carbon removal space. And so here we have like an industry that's in need of a decarbonization solution, and we have an industry that's willing to pay for that, and we have a very scalable sink for this great carbon removal technology, right? And all of that together just seemed like something that deserved a company, and so that's why we decided to found Ecolocked.
Okay, so if you can maybe like walk us through on the product side, I mean, what is the process? How does it work? How invasive is it to use your feedstock for the producer in the traditional cement or concrete facilities? If you could help us maybe to visualize for the audience like the process and understand your secret sauce or secret mix, I would say.
Yeah, definitely. So one, I guess, sort of goal we set for ourselves is that we want to make it as simple as possible for the industry to apply this, so that we actually can use it very soon without having to sort of revamp the entire process. And what that means is actually we integrate the biochar through what we call admixes. We call them Ecolocked materials. That's like our branding name there. And they can be dropped in during the concrete mixing process as it is today, at the plant or on site of a construction project. Now, how do we get to these mixes? We always start sort of with the recipe that would otherwise be used, right? The conventional recipe for a concrete, which can have many different shapes depending on whether, I have like a foundation, I have a floor slab, I have a structural pillar. And then we take that recipe, and based on our library of biocarbon materials and what we sort of identified as the performance predicting factors in the chemical and physical composition, we come up with a modified recipe that is optimized for CO2 and for the functional performance parameters that I want to have in this specific concrete, right? So some of them might care more, and some of them durability, freeze-thaw resistance, for example, might be more important. In others, it might be more thermal insulation. And so I can tweak that. And then the recipe we come up with is a modified version that contains these admix materials. And the admix materials then again are what we make out of one or maybe several biocarbons, which is of course something that I cannot go into too much detail on. But then essentially what we deliver for the industry is recipe plus admix material plus sort of the whole process around that when it comes to, for example, the carbon credit management and all of that.
So double clicking a little bit, and stop me if we go too far in terms of trade secret and recipe secret. But on the biochar as a feedstocks, I mean that you put in this mix. I mean, can you tell us a bit more like about for the people who don't know anything about this biochar, like where does it come from, what is suitable, and do you guys like produce that on site or buy it from like different suppliers? How does it work? How do you get this, main, I guess, material that goes into your mix?
Yeah. So first I want to say that we can do both. So we can produce it ourselves. We can also source it from others. The reason is really that so far we've focused on what we call sort of the material science behind it, right? So why is there so much material science? Maybe that's a good way to start this, because every biochar is different depending on the feedstock material I use, the waste biomass, and depending on the processing setup I use. For example, the temperature that I use for pyrolysis. Now I can make biochar, for example, out of waste wood, as many do nowadays. I can make it out of food industry waste, agricultural waste, or even manure, for example. And depending on that, it will have many different characteristics. Now, if you look at the market today, it's really still a nascent market, I would say. So in Europe, I think we have a production capacity of about 80,000 tons a year. But the interesting thing is this is growing by 80% a year. So it's growing really, really fast because biochar is getting popular as a carbon removal technology now. And so you have many different producers and suppliers, some of which are more looking to stay small, some of which are also looking into scaling around the world. And we think that's actually great because we see ourselves not sort of as a biochar supplier, but as the ones in the next step who are like refining the material, turning into a concrete additive. So we would love nothing more as when there are a couple of companies really scaling this up around the globe, who we can then work with in certain locations, procure their biochar, refine it and integrate it into exactly the recipes and the concrete types that producers there on site need. Nevertheless, it can very well be that if this all works out well, and if sort of we continue to see good demand for our solution, that in certain locations we might just have to set up pyrolysis facilities ourselves to meet the need for certain types of biochar and certain feedstock.
So, in terms of CO2 compensation, I mean, this biochar, when you produce it through the pyrolysis, infrastructure, I mean, you need the energy there. So, when you add that into the concrete, if you compare that to the regular cement, what is the ratio that you have in terms of like CO2, saved or removed? If that makes sense, what I'm saying.
Yeah, it does. So every concrete is different, but on average, let's say for the sake of the example, we have about 250 kilograms of CO2 in a regular meter cubed of concrete. And now our ambition is definitely to provide carbon neutral mixes or even carbon negative mixes across all the concrete applications that sort of our product works for. And that's like, we haven't tested it for all of them yet, right? But just what we know from the academic literature is that this is about 90% of concrete applications. And there's just a few niches where the solution maybe can't be applied. Now, that means these entire 250 kilograms can be abated through the use of the combination essentially of the carbon negative material we put in and the emission-causing material, the cement and aggregates that we take out, right? So the combination of both effects, and that's how you get to zero then or below zero for this meter cubed of concrete. What I want to mention there is it's important when we look at the biochar market nowadays, right? Like a lot of producers, typically, if the biochar ends up in the soil in agriculture, then the certificate would be sold to, the likes of Microsoft and Amazon and Stripe, who use it to compensate for their emissions. If we want to, in our case, we actually use the biochar physically in the material. So if it's compensating any emissions, it should be done right there, which means that the project end user should also be the one who's buying and retiring the credits, because otherwise you might have double counting, and that you want to definitely avoid. And sort of this is a new carbon or an extended carbon credit management process that we are currently setting up, developing, and also discussing with the MRV providers out there, because we really want to make sure that this is not like an offsetting solution, but truly a carbon negative additive that's just adding on top what's anyways done.
So what are the current and expected economics of Ecolocked? I mean, how much does it cost to use your admix versus regular, let's say the Portland, cement or the concrete? I mean, what is your business model and the future projection? If you can, share that a little bit with the audience.
Yeah, sure. So if we look at the future, like the business model, right? So the business model currently involves we produce we take biochar, we refine it into our admixes, and we sell it together with the recipe. And that involves essentially then the price of the material plus a license fee, which you could call our margin then as well. In the future, sort of whether we produce in certain locations ourselves or whether we license the entire post-processing, whether we license that out, or whether we maybe even vertically integrate and produce the biochar in other locations, that's TBD. There we really care about setting up value chains that are efficient, that are minimizing transport. But that's the essence sort of the business model, what I just said. Now, if we look at economics, it's actually quite hard to say, to tell you one number about the costs right now, because we are really in the pilot stage. We're just starting to do the first pilots, and what we've seen is every pilot is so different in terms of where we source the materials from, the feedstocks being used, the logistics, how we do the post-processing. It's all still very, very inefficient, right? So you can really imagine it as, okay, we have a new project that's maybe like 100 kilometers from here, and it's supposed to happen very, very soon. Okay, we find a biocarbon supplier whose material is suitable for that recipe. Then we need to post-process it, so we ship it around quite a bit. And so, right, this is really not how I imagine the setup in the future. In the future, we are very, very confident that we can get to a premium of between 5 and 20, maybe maximum 25% on the meter cubed of concrete in different applications. So the higher strength applications might be a bit more expensive. The lower strength would be very, very close to cost competitive. And that's actually quite a good deal, I would say, because this is not even sort of taking into account yet some of the functional improvements we can achieve. Maybe why is there still this premium? Well, what we have to do with here is materials that are notoriously cheap, cement and aggregates, right? And it's just for any material very, very difficult to compete with that. But interestingly, even there, we've seen price increases of 50 to 100% in recent years. So something is changing.
So I'd like to cover a little bit this section as well with you. I mean, you mentioned that pilot phase today, so still a lot to learn and to experiment. But I mean, you mentioned also like the market opportunity here. We're talking about 600 billion, if I use your term. So, how are you planning to scale your operation and streamline all of those process? I mean, and how do you working with those concrete producers? Like, how do you approach them? How do they receive you? Are you guys doing pilot with them? Are they like receptive to that? A lot of questions here, but just to try to understand like those different, steps where you are today and what's next. In a way, what keeps you up at night today?
Yeah, and that's a very fair question because there are so many different ways how you can scale this, but each of them has their challenges, right? So first thing we're doing this year, and I think that's the most important step, is to do pilot projects in different categories of concrete to really create a proof of concept. And a proof of concept in two ways, like in the technical way that I can showcase, look, this works not only in our laboratory, but it actually works out there. And then secondly, a commercial proof of concept in the sense like, okay, and there's actually companies out there willing to pay for this, both manufacturers, which is more than in the precast space, and real estate companies, which is sort of more in the project business. And so that's really important for this year. At the same time, we are preparing sort of the value chain which you will need for scale up. And what that means is essentially we want to set up almost a platform of many biocarbon suppliers, producers, traders, you name it, in the way that when we enter a new market and we have demand there from the construction side, then for any given recipe, we can very swiftly come up with the optimized biocarbon-based recipe based on locally available resources. So really this flexibility to deliver that location feedstock agnostic, that's the idea for the future. And there comes in the idea of the platform, right? And yeah. And then when it comes to operations, one thing that we want to do very soon, actually beginning of next year, and maybe when it comes to sort of what are our needs later, this is one of the things that are keeping me up at night now. We want to build up a demo plant, and by demo plant I mean a small plant that sort of contains all the steps from raw biochar arrives from the producer up until the point where I have like a blended, ground up, perfectly mixed packaged product that just needs to be shipped to the concrete producer and dropped in. And this plant we want to send up next year. And what's keeping me up at night there is the capex funding, which is, I guess, keeping up many climate tech founders at night. But that's really how we want to sort of show, okay, this is how it would work efficiently. And then this efficient organization almost like put all of that in a container and then reproduce that everywhere so that you kind of really localize almost like waste biomass to concrete value chains where you have like the pyrolysis plant, then you have this container with all the steps we need for the refining, post-processing, and ideally the concrete manufacturing plant is next door, and thereby you really have a circular process.
Thank you so much for sharing all of those amazing progress that you guys are doing. So, one question that I'd like to ask on the show, it's what's your personal opinion on the climate crisis? I mean, what would be your words to the people who feel demoralized, stressed, anxious, seeing all of the already visible consequences of climate change today? Are we doomed?
Yeah, that's a very difficult question, and I mean, to be quite honest, I'm also increasingly frustrated with political action. I'm based in Germany, and we've recently done things like almost stopped the combustion car ban in Europe. They were trying to stop it. Luckily, it still went through, but sort of so it's hard to stay motivated there. But when I see this entire space of people in climate tech, right? Whether that's founders, whether that's investors, and this increasingly large group of people willing to pour money into this as well. That sort of tells me, okay, there's still a chance. And I guess even though we need politics needs to set like the sort of the incentives, the framework conditions, but with this great bunch of people and all these ideas, if only a few of them really get scaled to where we all say they will get scaled to, right? Like everyone thinks that about their technology, but if only a few of them get there, then we can actually have a huge impact, and then we can maybe get back on a 2 degrees path, or 1.5. 1.5 is really ambitious as well. But right, so long story short, I think it's the technology side that is helping me there stay hopeful.
Well, thank you so much. So, any question that I should have asked you that I didn't do for this first part of the interview?
I think that was very comprehensive, and I hope I didn't talk too long in the different sections.
Maybe last one. How can the listeners of investors, founders, experts, CVCs around the world listening to the show can help you? What would be your ask?
Yeah, I mean, so I guess the first one, like I just said, right? So capex funding is a difficult topic. I think in the US there's more and more programs for that by the DOE, by DARPA, etc. In Europe, it's still more difficult, especially when you're at that stage where you're not fully commercial yet, but you still want to build a pilot plant. So if there is sort of landed funding providers, debt providers, I mean, we're talking to some, but in general, like if anyone has ideas, solutions, leads there, please hit us up, because yeah, that's not an easy one. The second one, which is maybe a bit easier, we're always looking for great talent, especially great talent with a background in the construction industry or even in concrete, like material scientists, concrete technologists. It's also a rare breed. And there's a lot of competition for them out there. So I can only say, like, hey guys, if you want to work in a climate tech company and try to solve this big crisis, then please hit us up. We would be very, very happy to welcome you. Yeah, and I guess finally, like I said before, whoever is interested in trying out our materials together, maybe together with their solution, if it's another decarbonization solution for concrete, or of course in a project, in a real estate project, in another municipal project to get carbon neutral concrete, hit us up, because we're very, very happy to do that.
Thank you so much, Mario, for your time. Incredible insight on the industry. I'm so excited to see amazing founders like you and people putting so much time and effort to make our world a better place, a greener world, and a more climate-friendly world as well. So thank you so much for coming.
Thank you very much, Guillaume. It was
Thanks again for joining us on the Tech for Climate podcast. I hope you enjoyed the show. Stay tuned next week for more climate tech insights. In the meantime, head on over to our webpage at startupbasecamp.org, where we have lots more insights and resources for anyone wanting to get involved in climate tech. If you find our resources useful, please consider donating to support our small self-funded team. Don't forget to subscribe and share with your friends. And see you next time.